Good morning, dears. Today we will see how to solve LR parser problem. Okay, so either it will come like this LR of 0, or simply it will come as LR, or it will come as SLR, means simple LR. Okay, so these all related with, all are collectively known as LR parser. Okay, so construct LR of 0 parser for the given grammar. The grammar is this. Okay, now we have to construct the predictive parsing table, and we have to check whether the input string open bracket a comma a closing bracket is accepted by the grammar or not. Okay, so for solving this LR parser problem, first we need to augment the grammar. Augmentation is nothing but the starting symbol. Okay, so s is the starting symbol, so simply we are writing s dash tends to s, so this is the augmenting grammar. Okay, and simply we are writing the remaining grammars from the question. Okay, now the next step is we have to find the closure. Okay, so closure, how we can find means s dash tends to S. So in this production, simply we are adding a dot here. S dash tends to dot S. Now after dot, a non-terminal is existing, right? So we have to write the further productions of this S. So S, two productions are there. S tends to open bracket L, S tends to A, right? So we are writing these two productions. And there is no other or non-terminal present immediately after a dot symbol. So by this we are stopping. If example, if here dot L is coming, means next we have to write the L productions also. But here there is no L coming immediately after the dot. So simply we are writing these three. Okay, now we are naming it as I naught. So this is the closure. Okay, the next important step is we have to find the go to. Okay, go to. What is the motto of go to is that we have to take this dot to the end of the production. Okay, simply we are moving one after another. That's it. Simple procedure only. Okay, so initially we have to move. For this go to, entirely we will focus on the right hand side. Okay, so we have to move this dot from this left side to the end side. So first we have to move this. So go to of, from I naught we are taking this S, right? I naught S. So in I naught S we are moving the dot. See, simply S dash tends to dot S, we are writing as S dash tends to S dot, and we are naming it as I1. See here the dot is reached to the end. Likewise we have to take all the dot from the left side to the end position. Okay, now in this I naught, the first thing is clear. Next we have to move this dot from this left side to the end side. So step by step only we can do it. So initially we have to take this open bracket, right? So I naught comma open bracket. So we are writing S dash tends to, we are moving the dot, open bracket dot L closing bracket. Now we'll see immediately after the dot a non-terminal is existing. So we have to write the productions of it. So we are writing L tends to dot L comma S, L tends to dot S. See, now after dot S is coming, so we are writing the S productions also. And collectively for all these production we are naming it as I2. Next we have to move this A, right? From I naught we have to take this A. So see, go to I naught comma A, S tends to A dot. Now we are naming it as I3. Okay, so I naught, all the three productions we completed. Next I1, in I1 see there is no production we need to take, right? Already the dot is reached to the end position. So we can leave this. Now in I2 we are having so many things to parse, right? So in I2 initially we are taking the L. After dot L is present, right? So we have to move this dot from this position to here. So I2 of L. So S tends to open bracket L dot closing bracket. Now you see in I2 there is another one L also present, right? L tends to dot L. So this production also you can consider. Similarly in I2 L, another one production is also there. So you will be writing that thing also. So L tends to L dot comma S. Now you will name it as I4. Next in I2, you have to move the S. Right. About the L productions you completed. Now next thing is I2 of S. So simply you are writing L tends to S dot and you are giving another name. Okay. Next what you have to parse in I2 open bracket. Right. So I2 open bracket. So S tends to simply you are moving that dot open bracket dot L. Now you see after dot a non-terminal is present. So you are writing all the productions of L. While writing, see you noted that after dot product there is a non-terminal S. So you will be writing that productions also. So already the same thing is existing. I2 only repeating here. So we don't need to give another name as I6. Simply it is repeating. So you are writing what is repeating? I2. I2 is repeating. So and you are rounding it. Okay. In I2 another one production is also there. A. So I2A you are again moving parsing. So S tends to A dot, that is also repeating. So you are giving as I3. Okay. So that's over from I2. In I3 you see nothing you need to parse. Already the dot is reached at the end. So you are leaving. And in I4 again you have to parse the closing bracket and you have to parse the S. Right. So I4 closing bracket. So what happened? S tends to open bracket L closing bracket dot. So dot reached to the end. You are naming the another I6. Okay. Now next in I4 what you have to parse? See there is a comma present, right? So I4 comma. Now L tends to L comma dot S. See after dot a non-terminal is coming. So you have to write the productions of that particular non-terminal. So we are writing the S productions and you are giving the name I7. Okay. Next in I7, next you see in I5 you don't have anything to parse. Already the dot reached to the end and these things everything we completed. In I6 also the dot reached to the end. Nothing you need to parse. In I7 only next you have to parse, right? In I7 see dot is here. So you have to take this dot to the end. This S you need to parse. This open bracket you need to parse. This A you need to parse, right? I7 comma S. So what will happen? L tends to L comma S dot. This is a new production. So you are naming another name. Now I7 open bracket. So that time again the same productions are repeating. You are naming it as I2. Now I7 comma A. What happened? Again the third prediction is repeating. So you are giving it as I3, right? So all the predictions we have come across. No, nothing else remaining, right? Next we have to construct the parsing table. So it is also very simple. We have reached till I0 to I8, right? So 8 states we are having. So we will simply write 0, 1, 2, 3, 4, 5, 6, 7, 8, namely go-tos. I0, I1, I2, I3, right? Likewise, we reach till I8, right? So that 8 states we have mentioned and here actions and go to. So what are all the terminal symbols we are having? Dollar, open bracket, closing bracket, comma and A. And what are all the non-terminals of the problem? S and L are the non-terminals, right? So we have written all those things. Next, how we will solve this? How we will fill this? Okay, it's purely based on go to, we will fill this. See here I0 comma S, we are leading to I1, right? I0 comma S. So in the place of 0, S, it is leading to I1. So simply here we will write the numbers alone. In go to we will simply write the numbers. So it is leading to I1. So you are writing 1, right? And what you see in I0 comma open bracket leading to I2. I0 comma open bracket leading to I2. Under this actions you have to write along with shift. So you are writing S2. So clear. Similarly, I naught comma A leading to I3. So see, I naught comma A leading to I3. So you have to write along with the shift. So you are writing S3. Right. Defaultly $1 will be accept. Okay. So you have to write initially this. Now I naught A we finished. I2 comma L, it is leading to I4. I2 comma L, it is leading to I4. So you are simply writing the number here, right? In go to, you are simply writing the number 4. Then what is the next? I2 comma S is I5. So we are writing 5 here. Then I2 comma open bracket leading to S2. So you are writing I2 is, we are writing here as along with the shift S2. So likewise you are filling all the shift. Okay, so last thing, what is we got? I7 comma A, that is leading to I3. I7 comma A leading to I3. So S3 we have written. Next you could see some R here, right? How you will fill this R? Reduction. R is relating reduction. Okay, now we will see how we are filling that. For that, actually we need to consider in what all the production we reached to the dot from this go to. Okay, so we could notice that in these 4 states, in I3, I5, I6 and I8, you could note that the dot is reached to the end position. Right, so we are writing all the productions here initially. Okay, then here immediately to this dot, if it is a non-terminal means you could consider the follow of that particular non-terminal. If immediately after the dot there is a non-terminal is not present, if it is a terminal symbol means directly you will consider the left hand side and we will find the follow of that particular as. Okay, then we have to check the production number also. So for checking the production number, we will not consider this augmentation. Starting from this 1, 2, 3, 4, like this only you will consider the production number. We will not consider the augmented grammar for it. Okay. So accordingly you will find S tends to A is the production number 2. So we have to check the follow of S. Follow of S is dollar, closing bracket and comma. So here it is number, production number is 2 and it is reduction. So we have to write R2. See in I3, dollar, comma and closing bracket, right? You are writing R2, R2, R2. Similarly in I5, production number 5 it is. So dot immediately after near to dot, S is present, non-terminal, follow of S is the same symbols. This production number is R4. So you have to R4 in the 5th state. So you are writing to the respective places. Similarly, I6, this is a production, right? It is number 1, first production. So immediately to the dot operator, there is a terminal symbol present. Even after that, there is a non-terminal existing, but still we will not consider this. Immediately the neighbor is a terminal means we will see the left hand side. So it is S. Again follow of S, the same symbols. You have to write R1. Okay. So finally I8 also, this is a production, it is number 3. And again a follow of S. So these are all the follows. So this is production number 3. So you are writing R3 in 8 state. Right. So this is how you will be filling the parsing table. Next we want to check whether the given string open bracket A comma A closing bracket is accepted by this grammar or not. Okay. Seeing this parsing table only, we will find that okay. So this is the format, stack, input string and explanation. Initially the stack contains 0, input string contains the question, open bracket A comma A closing bracket and followed with a dollar symbol. Okay. So initially what we will do, we will check the 0 and we will take this starting thing. 0 open bracket. So action 0 open bracket. So we have to check in the parsing table. Action 0 open bracket, it is S2, right? So we will writing S2 here. So if it is shift means you have to push this open bracket and 2 from this S2 to the stack. So simply we are pushing 0 open bracket 2. Okay, and what is remaining here? We pushed this remaining a comma a closing bracket dollar, right? So next what you have to do? 2a, right? Action 2a. Check in parsing table. 2a is S3, right? So 2a is S3. Again we have to shift this a and 3 to the stack. So we are pushing a and 3. Okay. So what is remaining here? We pushed this a, comma a, closing bracket, dollar is there, right? We have written. Now next thing is this 3 and comma, right? Action 3, comma. Check in parsing table. 3, comma is the R2. So here it is comes the reduction. For shifting, we simply push. For reduction, what you have to do? R2 means we have to look the second production. Second production is this, S tends to A. See here, how many tokens are there? Only one token is present. So, how you can find this R value means number of token into 2. Right? Number of token here is 1. 1 into 2 gives R value 2. So, you have to pop 2 symbols from the stack and you have to push this starting symbol. So S tends to A, right? So this is the starting symbol here. S, left hand side symbol, right? S. So you have to push S. So now you have to pop 2 symbols and you have to push S. Now you see S and comma. See in S and comma. So there is no relation here. We can't find anything here, right? S to comma. So simply we are considering the nearest to value 2s. Okay, 2s is relating 5. So 5 we are pushing here and then 5 comma you are checking. Okay, 5 comma what is it? R4. Right, again you are writing 5 comma is R4. So this is the fourth production. Number of token 1 here. So R is equal to 2. You have to pop 2 symbols and you have to push this left side symbol L. So you are popping 2 symbols and you are pushing the L. Again L to comma, there is no relation. So you are checking the neighbors. 2L. 2L is 4. So you are pushing this 4 and next 4 comma you are checking. Okay, action 4 comma is nothing but S7, right? So you are pushing this comma and you are pushing this 7 to the stack. Okay, so yeah, likewise you are doing that, pushing the comma and the 7. Next you are checking with action 7A. 7A is again in the parsing table, it is S3. Okay, so you are again it is shift. So you are pushing this A and 3 to the stack. So again you are pushing A and 3 to the stack. Next is 3 and closing bracket, right? Action 3 closing bracket is in the parsing table, it is R2. So you have to look the second production, that is S tends to A. Here number of token is 1. R is equal to number of token into 2, that is 2 you are getting. You have to pop 2 symbols from the stack and you are pushing this left hand side S. Okay, and you are popping 2 symbols and pushing this S to the stack. Okay, S closing bracket is we can't relate, so we are considering the nearest 2 numbers. 7 is in the parsing table, it is 8. So you are pushing the 8 into the stack. Now you are seeing 8 and closing bracket. Action 8 closing bracket is reduction again R3. So you have to look the third production, that is L tends to L comma S. See friends, you could see that here number of token is 3. Right? L comma S. So R is equal to number of tokens into 2, that is 3 into 2, which gives you 6. So you have to pop 6 symbols and you have to push the left hand side L. So you are popping 6 symbols including comma. Okay, you are popping 6 symbols and next you are pushing the L. Okay, see you are pushing L. Okay, now L closing bracket you can't relate, so you are looking 2L. In the parsing table 2L is 4, so you are pushing the 4. Next you are checking 4 closing bracket, which gives you S6. So again you are pushing this closing bracket and 6 to the stack. Okay, you are pushing it. Now here nothing left, only dollar is there. So what is remaining, that you have written here. Next what will happen, $6. So at that time you will get R1. Now you have to check the first prediction, which is S tends to open bracket, L closing bracket. See friends, here also 3 tokens are there, right? Open bracket, L closing bracket. So R is equal to number of tokens, that is 3 into 2, which gives 6. So again you have to pop 6 symbols and you are pushing this left hand side S. So popping 6 symbols and you are pushing this S. Okay, S to dollar you cannot relate. So nearest to two things, 0 and S you are checking. In the parsing table it is 1. Now action $1, which gives you accept from the parsing table. So you could say that the given string is accepted by the grammar. Okay, so actually when you are understanding it, it is simple problem. Okay friends, I think there is no doubt. If you are having any queries, kindly put it on the chat box. Thank you for watching. Kindly subscribe my channel and like the video, share the video. Thank you.